Okay, this video is for 11.6G, area of two-dimensional figures. Alright, so today in notes, or for our notes, we talked about the area formulas for three different types of shapes. We talked about it for trapezoids, for rhombuses, and for kites. So let's do one of each of those. Let's look at problem number 1. This is a trapezoid. And the formula we discussed in class about a trapezoid is area equals 1/2 times height times base 1 plus base 2. Now, so the key to this is being able to identify what each of those pieces are in your trapezoid and then multiplying and adding everything together. So the bases are pretty simple. The bases are going to be the two sides that are parallel to each other. And it doesn't matter if the big one's base 1 or the little one's base 1, just that one of them is base 1 and one of them is base 2. So I'm going to call 9 base 1. I'm going to call 17 base 2. Now the height is the other thing we have to identify, and the height is just like it was for our parallelogram. So the height is going to be this perpendicular line, not the slanted ones, but the perpendicular one that you create when you just kind of drop a line from one of the bases to the other base. So we'll call 14 the height. So now that we've got all this information, let's plug it into the formula and we will find our area. Area equals 1/2 of the height, which is 14, times base 1 plus base 2, which is 9 plus 17. So let's simplify this a little bit. This becomes 1/2 times 14, and then 9 plus 17 is 26. And let's multiply 14 and 1/2 together first. So 1/2 times 14 is 7, so this becomes 7 times 26. And then when you throw 7 times 26 into your calculator, you get 182. So the area here, and no units were given, so the area here is 182 whatever units squared. Alright, let's take a look at a different one now. Do number 3. Number 3 is a kite. Now, to find the area of a kite, we need to plug it into the formula, simplify. It's just that the formula is different again. So, the area of a kite equals 1/2 times diagonal 1, so the length of one of the diagonals, times the length of the other diagonal. So for a kite, we're looking for the lengths of both the diagonals, and then we're going to multiply them together, and then multiply it by 1/2. So, as you can see, this length right here, this is one of the diagonals, and that's represented by 9 feet. Here's our other diagonal, and that's represented by 13 feet. So, we'll call 9 feet diagonal 1, we'll call 13 feet diagonal 2, and now we have all the information we need. So, area will be 1/2 times 9 times 13. Now I'm just going to put that straight into my calculator. I'm going to call 1/2 0.5. So 0.5 times 9 times 13 equals 58.5. This time we do have units. You can see they are feet, so feet squared. And that is the area of this kite. Alright, let's do one more. We'll find a rhombus. We can do number 4. Now, the nice thing about a rhombus compared to a kite is they actually have the exact same formula. So the formula for the area of a rhombus is going to also be 1/2 times diagonal 1 times diagonal 2. In this problem, though, it's not as easy as figuring out what the diagonal lengths are. They give us what this piece is and what this piece is, and then they do the same with the other diagonal. So if this piece right here is 8, and this piece is 8, then the whole diagonal is 8 plus 8, which is 16. And for our other diagonal, if this piece is 4 and this piece is 4, then the whole diagonal length is 8. So I'm going to call 8 diagonal 1, I'll call 16 diagonal 2, and now we've got enough information to apply the formula. So, area equals 1/2 times diagonal 1, which we said was 8, times diagonal 2, which we said was 16. Put that into your calculator and you get 64. And again, they don't have units here, so it's just 64 units squared. Alright, let's flip to the back real quick. We'll do one more where we have to work backwards. So let's look at the trapezoid. Remember, the area of a trapezoid equals 1/2 the height times base 1 plus base 2. So you can see right here, 8.7 centimeters is the line that's perpendicular with one of the bases. That is the height. You can see down here, 8.9 is one of our bases, so we'll call that base 1. And what we're missing is base 2. Now, this is important information in the instructions. Quadrilateral has an area of 64 square units. So we're going to set our area formula equal to 64. So 64 equals 1/2, and our height is 8.7, and then base 1 plus base 2, so that's 8.9 plus base 2. And now we have to solve for base 2. So the first thing we should do is multiply 1/2 and 8.7 together. So we get 64 equals 4.35 times 8.9 plus base 2. Now divide both sides by 4.35. And then we get these 4.35s cancel, and we get 64 divided by 4.35 equals, we'll move over here to finish it up, 14.71, and that equals 8.9 plus base 2. And then the last thing we have to do is subtract 8.9 from both sides, and that way we will get base 2 by itself. These 8.9s cancel out, and 14.71 minus 8.9 equals 5.81. So 5.81 equals base 2. And remember, these units are centimeters, so 5.81 centimeters. And that's our answer.